Okay, hello grade 11s. This video is going to look at converting from a given mass of one quantity in a chemical equation to a mass of another element, another compound in the chemical equation. Could be an element or a compound. Before you get going on this video, you'll want to open up the mass to mass student guide. So there should be a PDF of that, and print off at least this one. Okay, so the one that looks like this, there's a couple of options that have varying levels of support. So some have the steps written in, some don't. But have at least this one, and then have a pencil so you can write on it and erase it to do different problems. And if you don't want to print it, you can obviously just draw it out. All right, so let's get going. So we were dealing with doing a baking soda and vinegar volcano in the last video, and we dealt with converting from mole to mole. But of course, the problem in chemistry is our equations are in moles because we want to know how many particles of one substance reacts with how many particles of another to produce how many particles of our final product. But we can't measure particles on a scale, we can't measure moles on a scale. So we have to convert these values into mass in order to work with them in the lab. So my perfect volcano needs 42 grams to make my nice perfect sized volcano. So 42 grams of baking soda. So that's where we're going to start from. So the mass that we are given is 42 grams. And we know this is our baking soda. So this is baking soda. And I need to somehow get that into moles, but of course we've covered that, so we know how to convert this into moles. We simply need the molar mass value for baking soda. And the molar mass of baking soda is 84 grams per mole. So if I want to convert along this arrow to get the moles of my given, which is the baking soda, I need my equation. We've got moles equals mass divided by its molar mass. So we want moles. We have mass of 42 grams. Please get in the habit of always having your units in your equation so you can see if things cancel out. We're going to divide that by its 84 grams per mole. All right, we can see the unit we want to end up with is moles, and our grams cancel. So grams divided by grams cancels out. We're left with 42 divided by 84. It gives us a nice, I don't want my orange here, gives us a nice 0.5 moles of baking soda. So great, we've got it into moles of our given. Now, of course, we want to complete the step that we did from our last video. We want to convert moles to moles. So we need moles of given to become moles of required. So we need to use the one to figure out the other. And if we recall, we can't just assume if we have 0.5 moles of our given, it's going to be 0.5 moles of our required. We need to go back and check our balanced equation. So thankfully for baking soda and vinegar, nice and straightforward. We'll do a slightly more complicated example in the next video. So we've got our baking soda and our vinegar equation there. We go back, we check it, we make sure it's balanced. It's a 1-to-1 ratio. So again, to convert from given to required, you've got to multiply the moles of your given by the molar ratio of the two from the equation. All right, so we are going to multiply our 0.5 moles of our given times, this is the molar ratio. All right, so you go back, you need the one that you want to end up with to be on the top so that the other one will cancel out, your given will cancel out. So we have 1 mole of vinegar, and that's our required, divided by 1 mole of our given. And again, those numbers coming from our molar ratio. So there's our molar ratio for given to required. And again, this is moles of given as well. Just put the G on there. So this is also moles of given. So moles of given are going to cancel out. This happens to be 1, so that's a nice, easy calculation. 0.5 times 1 divided by 1 is, of course, just 0.5. So we now have 0.5 moles of our required, and in this case, this is our vinegar. Okay, so our required is vinegar. When you're working through your equation, you don't need to label these as vinegar and baking soda as long as you know what your given is and your required is. You might want to at least label the mole circles in the middle so you keep straight which one's given and which one's required. All right, so once you've gotten to that step, your balanced equation, we don't need that anymore. So I'm just going to cover that back up. All right, so we no longer need our balanced equation. So we can just ignore that now. We have what we need. We've got our 0.5 moles of vinegar, but again, we can't weigh that on a scale. I'm trying to make a volcano here, so I can measure 42 grams of baking soda, but I can't measure 0.5 moles of vinegar. So I've got to put that back, of course, into something I can measure. So I'm going to go back to grams. All right, so this is now going to be the completion of our path. We want the mass of the required, which is our vinegar. And we've got to get back there. And how do we get back there? We have to, of course, go from moles to mass using the molar mass, but this time the molar mass of vinegar because we're operating on the vinegar side. All right, so our equation, same equation, we just have to rearrange for mass. So mass equals moles times the molar mass, and you should be good at rearranging these equations by now. If not, please get some more practice in. So our mass equals our 0.5 moles of vinegar times its molar mass, which is 60.05 grams per mole. Didn't quite plan out where I was writing things as well as I could have. And we are going to cross out the moles. So now the moles cancels out, because it's moles top and moles bottom there, and you are left with the unit you wanted, which is grams. So all I have to do is do that calculation, and you will figure out that you end up with 30.03 grams there. All right, and I think I had slightly different significant figures the first time I did this, so we'll just erase the 0.3. So 30 grams of vinegar. And there is our solution. All right, so we started from our 42 grams. We converted it to 0.5 moles of baking soda using baking soda's molar mass. We converted using the balanced chemical equation through the molar ratio of your required to your given. Required goes on top, so you end up with moles of required. Given goes on the bottom, so it cancels out with moles of the given. Now you've got your moles of given, can't measure it, so convert back to mass of the required, sorry, I think I said given there, mass of the required using the molar mass of your required. So you can do this for any two elements in any two parts of a chemical equation. You could compare your given and your required could both be reactants. Your given and your required could both be products. So if I produce 20 grams of one product, how much of the other product is going to be produced if there's two products to a chemical reaction, if there's three products to a chemical reaction. But in any case, you always simply compare two parts of an equation. All right, so you can't compare three at the same time, just two. You'd have to do the whole process again to compare to a third one. So what does this all look like in the end? So if we just flip one back, we can see our equation here. So there's our balanced chemical equation. One particle of baking soda reacts with one particle of vinegar. We started with this 42 grams. So if I want 42 grams of baking soda in my reaction, that converts to 0.5 moles of baking soda. These are the exact same thing. These are the exact same number of particles. 42 grams of baking soda is half a mole of particles. Same for vinegar. Now that we've got our 42 grams, we converted that. We wanted to know, we said, okay, it's 0.5 moles of vinegar that we want to be the same as the baking soda, so we get a 1-to-1 reaction. And 0.5 moles of vinegar is 30 grams of vinegar. This is the exact same amount if I measure on a scale. I can't measure in moles, but if I measure 30 grams, I'm measuring 0.5 moles of vinegar. And that's how we're getting our 1-to-1 reaction of particles between baking soda and vinegar. But the masses are different. So you must go through that heart of the equation. All right, so we must always do this. This is the heart. You've got to go through it because you cannot equate the masses in an equation directly. You can't equate 42 grams and say I'm going to react to 42 grams of vinegar. You can't do it. Those masses are the same amount of particles, even though the masses are different. All right, so that is doing mass to mass. In the next video, we will walk through water, which has a slightly more complicated molar ratio. But again, the only thing that changes about all of this when your molar ratio is not 1-to-1 is this little tiny bit here. Just pulling those numbers out and just changing them. So this could be 2 and 3, it could be 4 and 7. It's really no harder. But just instead of 1-to-1, you actually have to do a slight multiplication, 0.5 times 2 divided by 3 or something. All right, this is the only thing that changes when your balanced chemical equation isn't 1-to-1. All right, so that is it, and you can go straight to trying these mass-to-mass equations if you're comfortable with that, or you can check out the next video on water with a slightly different molar ratio there.